Attributes and transformations of cubic functions. Remember, the cubic function is f of x equals x cubed, or at least the parent function is x cubed. Let's look at a graph of this, and we can develop a graph by coming up with a t-table and plotting the points. So let's choose some values for x, -2, -1, 0, 1, 2. We get our y values by substituting into x cubed. So -2 quantity cubed is -8. -1 quantity cubed equals -1. 0 cubed is 0. 1 cubed equals 1. 2 cubed equals 8. So plotting these points on the coordinate plane, we have -2, -8. -1, -1, 0, 0, 1, 1, 2, 8. And sketching in, here we have our graph of a cubic function. And we can see that for this parent function, the domain is all real numbers, or from x can go from -infinity to +infinity. The range is also all real numbers, or y can be any number from -infinity to +infinity. The x-intercept is the origin, 0, 0, and so is the y-intercept. Let's look at some transformations. Example 1. Okay, we're going to compare our transformations with f of x equals x cubed. So we'll look at f of x equals 2x cubed, f of x equals 0.25x cubed, and f of x equals -x cubed. Looking at a coordinate plane with all four graphs, we see this. The parent function is here in black. F of x equals 2x cubed is a vertical stretch, and we see that graphed here in blue. F of x equals 0.25x cubed is a vertical compression, and we see that here in red. And f of x equals -x cubed is a reflection over the x-axis, and we see that here in purple. In general, if we have an equation of the form y equals a times f of x, when the absolute value of a is greater than 1, we have a vertical stretch. When the absolute value of a is less than 1, we have a vertical compression. When a is less than 0, or negative, we have a reflection over the x-axis. Okay, let's look at another example. Again, comparing always to f of x equals x cubed, we'll look at f of x equals x cubed plus 2 and f of x equals x cubed minus 4. Looking at these three graphs, again, the parent function is here in black. F of x equals x cubed plus 2 is a translation up 2 units, and it's here in blue. F of x equals x cubed minus 4 is a translation down 4 units, and it's here in red. In general, y equals f of x plus k. When k is greater than 0, we have a translation up k units, and when k is less than 0, we have a translation down k units. Okay, looking at a third example, again, always comparing with the parent function, f of x equals x cubed. We'll look at f of x equals x minus 3 quantity cubed, and f of x equals x plus 2 quantity cubed. Here we see the three graphs. The parent function is here in black. F of x equals x minus 3 quantity cubed is a translation right 3 units, and it's here in blue. F of x equals x plus 2 quantity cubed is a translation left 2 units, and it is here in red. I'm going to change this slightly because I've been seeing it differently. Let's change this really quickly to y equals f of x minus h. When h is greater than 0, we have a translation right h units. When h is less than 0, we have a translation left h units. And that gets tricky because we need to remember h is following a minus sign. Finally, if we look at the attributes of these transform cubic functions, we see certain things, certain features that are common no matter what the transformation. First, the domain is still always all real numbers. The range is also always all real numbers. And each of these cubic functions has exactly one x-intercept and exactly one y-intercept. Also, all of the cubic functions have rotational symmetry about a point.